There we go. All the very big numbers that came out from June, from all the precipitation in June. So kind of run through some of those numbers and then bring it back to current conditions and the future outlook after that. So let's see, we'll try slideshow mode here. Do you see the right slides, or do you see the
No,
presenter mode?
we see the presenter mode.
All right.
There you go.
No. Okay. Okay. If that works, we'll do that.
Yep.
Yeah. So, I think, well, as everyone who is east of the divide, at least, is well aware, May and June were both incredibly rainy months, and we'll try to run down some of the stats on that, and just show some of the records that were broken during those months in terms of rainfall. So this map shows June precipitation. So from the PRISM data set, and then also from CoCoRa's observers. And so you can see anywhere that's in the yellow there is more than 8 inches in June. And so there's a couple spots in there. I think the winner of the winner, quote unquote, from the CoCoRa's observers is this one in northern El Paso County with over 10 inches, another one near Colorado Springs with over 10. But you can see widespread 8 inches, like this orange color is 6 inches. So just huge rain amounts across kind of everywhere on the Eastern Plains. And if you're interested, we threw together if you want to like loop through individual days, there's a link to where you can kind of step through the days in June and see when the big rain events were. And then if we add May and June together, because May was also super wet on the Eastern Plains now, and the color scale is a little different here. So here the yellow is 10 inches. So, almost all of northeastern Colorado had more than 10 inches of rain in just May and June. And some spots with 14, 15 plus. So yeah, very, very big amounts there. So we'll try to put those into some context here. So this is from that PRISM data set. So this is ranking this June 2023 against all other Junes. And so anywhere you see it going back to 1895, and so anywhere you see this really dark green color, it was the wettest June on record. And so in this data set, and so you can see that, pretty much basically all of Elbert County was wettest June on record, most of El Paso, most of Lincoln, et cetera, most of Morgan. So just kind of incredible numbers there. And then we can do the same thing, but comparing this June against all other months. Doesn't have to be June. And so you can see there's pockets where it was the wettest month period on record in this data set. That's what the dark shading, the darkest shading here shows. So there's pockets around Colorado Springs and into Elbert, Lincoln, Washington counties, where it was the wettest month period. And then we'll kind of look at the same thing for May and June. So this is May plus June, ranked against all other May plus Junes. And again, most of Northeast Colorado was the wettest on record going back to 1895 for that 2-month period. And then we can also look at, this is May and June of this year compared to all other 2-month periods in the whole record. And basically anywhere you see the color here, it was the wettest 2-month period of all in these areas. So it's kind of the superlatives keep appearing when we look at the data for June and for that May-June period. Just incredibly wet across much of eastern Colorado. And of course, we've seen the issues with flooding in a lot of places. And we'll look at some of the other severe weather in a minute. And then if we zoom out to the first 6 months of the year, this is January, the first 6 months of the calendar year, a lot of places are wettest first 6 months of the year on record as well, where you see that darkest shading. And again, most of eastern Colorado is in the top 10 wettest for January through June. These maps are the NOAA's kind of official data, just came out this morning for June. And so these are basically the same maps, just with a different data set, and they pretty much look the same, aside from some small differences in detail. So in that data set, it was the 6th wettest statewide, whereas in the PRISM data set, it was the 4th. But if you break it down by county, it shows Morgan, El Paso, Lincoln, Elbert, Douglas counties all had their wettest June on record there. And this is the NOAA data set for May, June, again, May and June. And you can see that most of those same areas are wettest on record. And the NOAA data set for the first 6 months, also wettest on record for those same areas we were looking at. So pretty incredible numbers. We'll look quickly here at severe weather, because it wasn't, rain was one of the big stories, but the other severe weather was also a big story during June. And so this map shows preliminary severe weather reports for June and flood and flash flood reports across Colorado. So the red dots are tornado reports, the green is hail, the blue is thunderstorm winds, and then the brownish color is flood or flash flood reports. And there's a lot of green dots on the map of hail reports around the state. And we've had more since July started as well, but those aren't shown on here. I'd encourage you to check out this write-up from the Boulder National Weather Service last week, where they went and kind of reanalyzed the tornadoes of June 21st, mostly in Washington County. So that all those dots don't even show up on the map here, but they've found 36 tornadoes on that one day, which is the most that's ever been recorded on a single day. There's some caveats around that, because obviously there's a lot more people out taking pictures and videos of tornadoes now than would have been the case in the past, but still a pretty remarkable number. And most of those were in Washington County. The next day after that was the Highlands Ranch tornado. And then on the 23rd was the tornado near Grenada. That was the first EF3 in Colorado since the Berthoud tornado in 2015. So it was a huge month for severe weather as well. 310 severe hail reports, 77 2-inch hail reports, that's roughly golf ball size, 14 3-inch hail reports, that's like bigger than baseball size. So we'll kind of tally some of those up as well and see where those rank in comparison to other months. But this is certainly a huge month for severe weather across eastern Colorado. And we now have these updating in real time. If you want to like look at these maps, you can zoom in and see the little dots on there and you know what date they were from and things, if you want to go to that link. All right, so I'll show here last then just a few of these quadrant charts that we make, and sometimes we show these during these webinars. So just to orient you here, this is precipitation along the x-axis and then temperature along the y-axis. So if you're in the upper left, that's the drought quadrant, the warm and dry. Upper right is warm and wet, lower left is cool and dry, lower right is cool and wet. And I'll show this for a few different locations and a few different time periods. So this is for Colorado Springs, the Colorado Springs Airport, for May and June. And so we can see 20, and all these 2023 will show up with the star. So the wettest May and June on record at Colorado Springs, just beating out 2015, a little bit cooler than average over that time period. So they had 14.84 inches for May and June compared to the full year average, which is 15.91. And then if we add there's been more storms in the last week and a half since July started. So they're now up to 16.85 since May 1st. So topped the annual average just in those 2 months and a couple weeks. So pretty impressive there. This is the similar one for Lyman for May and June. So not quite the wettest May and June at Lyman. 1967 was a little bit wetter there. But interestingly, a bit warmer than average at Lyman, in addition to being extremely wet over that period. And then now we'll kind of zoom out to look at even bigger areas. And this is just for June. This is the statewide average for Colorado. And so you can see where 2023 ranks here, a little bit wetter than 2009, which was kind of the last cool and wet June around the state, or the most recent one. So you didn't, statewide, it didn't quite top some of these other years like 1927 and 1965, 1949. This is largely because the west slope was a bit drier than average during June. So certainly Eastern Plains was extremely wet, but it's dried out a bit west of the divide. So in the statewide average, we don't quite get to that record. But if we look at just Northeast Colorado, this is the Platte River drainage. So basically everything that drains into the Platte, and you can see it was the wettest June on record for that corner of the state. And then get ready for the really incredible one here, which is Elbert County for June. And so this is Elbert County in June, and you can see it went so far past 1965 in terms of the rainfall. So just an incredible amount of rain in, kind of relentless rain in June across Elbert County. And the data only just came out an hour or so ago, so I haven't made all the different ones yet, but we'll see what these look like I imagine they'll look pretty similar for like Lincoln County and El Paso and so forth. So like almost 8 inches of rain for June on average across Elbert County. All right, and then the last one, I will let Peter talk about this one, because this is the soil moisture graphic that he put together.
Yeah, do you want me to show the animation?
Oh, if you've got it, then sure. Yeah, I just grabbed a snapshot here.
Yeah, I'll pull it up on my computer.
Okay,
and then share
well,
my
I'll stop sharing then.
Out of curiosity, was that presentation in presenter mode or gallery mode for anybody else? And one person say it was.
Oh, okay.
I think
Yeah.
it was okay for me.
Yeah.
I think I was getting the full screen on it. I don't know if anyone else was having my luck, but yeah, this is just a loop of top meter, or basically the closest 40 inches to the surface soil moisture percentile from the beginning of May through the end of June, where you see the blue colors are where you have the wetter soils, where you have brown colors or drier soils, or below 30th percentile. And so the loop starts at the beginning of May, and you can see this big brown spot across eastern Colorado at the beginning of the loop, whereas you have blue across western Colorado, which is already a big change from where we were last year, since last year we had below normal soil moisture across the west slopes as well. But you really see the wet soils develop rapidly across much of eastern Colorado when we get those first big rainstorms the second week of May, and then that just kind of continues through June. So that's the loop I've got for soil moisture. If there's any questions on that or what we've covered so far, maybe we can take those now. But Russ, was that your last slide, and then were you going to pitch it over to me, or should I pitch it back to you?
Nope, that was all I had. So I figured that was a segue over to you. Yeah, but yeah, happy to take any questions if people have them, or you can put them in the chat.
If there aren't any questions, I do want to say that was really great stuff. I thought that was an awesome overview of what we've been looking at the last 2 months in terms of weather. What I'm going to focus on today is how our surface water supply has responded. And I feel like we got that off to a really good start with the soil moisture graphic, but I also want to look at stream flows and reservoir storage. And I'm going to start with this 28-day average stream flow graphic. But before I blow it up big so you can really see it, I just want to point out this percentile classification key, because it won't show up when I blow it up big. When I blow up this map, anything in the light blue or dark blue is at least 76th percentile, and the black is record high. And then anything in green is in the normal range. So you can see here, if I blow this up, that stream flows over the last month or so across the state have been well above average. And of course, with what we just saw for eastern Colorado, that's not particularly surprising that we have all these dark blue and black dots where we're seeing record high flows or flows above the 90th percentile. But then we also have good flows on the west slopes, and that makes sense too because we had a good snowpack here. So it's just kind of rare that we get to show a stream flow graphic like this across Colorado, where sure, there's a few gauges that are lagging a little bit for one reason or another, but the whole state paints a really nice picture with above average flows. And we just haven't seen a lot of stream flow maps like this lately. Let's see, I need to find a way to move that out of the way. Okay, let's see. I'm going to, instead of starting with reservoir storage, let's start with the hydrographs. This is looking at cumulative stream flow over the last kind of year and a half period. So what we're looking at here is the black line is showing the stream flow. And this is actually day-to-day stream flow. I'll show cumulative in a second, but this is showing stream flow for the Yampa River at Steamboat Springs over the calendar year of 2022 and the start of 2023 in black. The green shaded area shows the average range where you can see that big spike that we expect around the runoff season. Blues show where it's above normal, browns show where it's below normal. And you can see we started this year with below normal base flows for the Yampa, and then we spiked up and had a pretty good peak to our runoff above what our normal peak would be. A little bit early, but above normal. And we're kind of tracking back down towards base flows at a normal pace now. And this is fairly similar to what you'll see with other major rivers around the state. So, or at least on the west slope. So we'll talk about the South Platte here in a minute. This is the Colorado River at the Colorado-Utah state line. Even a little bit more dramatic here that, yes, we started with below normal base flows, but had a really nice high peak for stream flows. And then it's important to keep in mind that the Y scale here is not linear. So the more you go up on this graphic, the more kind of one visual unit increase actually means. So you can see here down at the bottom, we're at 1,000 CFS, here at 10,000, here we're at 70,000. So again, not linear. So the higher up you go on the scale, the more kind of meaningful that is. Here we're looking at the Gunnison River near Gunnison, and similar story. And I'll just rifle through a couple more of these. The Animus, yeah, again, a nice high peak, and we're still a little bit above average now. And then here's the South Platte, where we see, you know, base flows were kind of up and down throughout the winter, not necessarily below normal, but you really see when that rain hit in the second week of May, things spiked up. And then again in June, when the wet conditions continued, like Russ was showing. And right now, the South Platte at Fort Morgan is at record high volume for this point in July. But you can see in general, we're just up around the high end of the historical distribution. Not quite where we were in the floods of 2013, but right up there with some of the highest flows that we have seen on the South Platte over the last few weeks. And then here is the Arkansas River near Avondale. This was a part of the state where, you know, the contribution of stream flow that comes from seasonal snowpack, we were expecting to be a bit lagging because a lot of this area was a bit further behind in terms of snowpack this year. And because of the wet spring, we really ended up more on the above normal side of things. So there, the wet spring definitely doing us some favors. I'll go ahead and also show some of the cumulative flow graphics. So this is showing if you integrate from the beginning of the calendar year through current, how we stack up historically. And if this doesn't load in 1 or 2 seconds, I'll go ahead and move on and just say that they're all above normal. You can kind of see it here. The South Platte is this one in the middle here. The green range is what we see in a normal year. The blue range, the blue line is the record, which is way above what we're seeing this year, but we're still seeing flows on the South Platte way above what we see in the normal range. All right, now I do want to show a little bit about reservoir storage. And sorry, I've just got this Zoom bar up top here that I'm struggling to deal with, but I want to show the statewide kind of reservoir picture first, where much like stream flow, it's rare that I get to show a map with all these greens and blues and very little yellow and orange and red. where what we're seeing here is percent of normal reservoir storage at the end of June. So the green is right in the normal range, 90 to 109% of normal. And then the blues are anything above that from 110 to 150 plus. And the percentages are given next to each reservoir. And what you can see here is that most reservoirs in the state are around or above normal. A number of our major reservoirs have filled. I'll show that a little bit better in just a minute. Lake Powell and Meade, still low, but we probably, with the good snowpack this spring, bought a little bit of time on that slow-moving disaster. But across more locally, conditions are quite positive right now. Here's a graphic of reservoir storage for Lake Granby, similar to what I was showing with the stream flow, where the black line shows what's happened over the last calendar year and a half. And the green shaded area is what's normal, blue shaded is above normal, brown shaded is the below end of normal of the historical distribution. Lake Granby was in decent shape at the beginning of 2022, did fine in 2022, and then definitely filled and spilled in 2023. Definitely not the case with all our major reservoirs around the state. Blue Mesa was quite low in 2022, and a below normal snowpack year didn't do it any major favors. You can see where things we expect to spike up in 2022 didn't as much as normal. But then 2023, we made a big recovery, and Blue Mesa, you know, we're not full, but back to kind of normal operating schedule there, which is really good to see, especially when we consider how much water was released downstream from Blue Mesa during this whole period of time as well. McPhee Reservoir in southwest Colorado, similar story where, man, we filled fast once that snow, that great snow in the southwest portion of the state started melting. And then some of the bigger reservoirs further down some of these river channels, Navajo Reservoir further down the south, San Juan River Channel. Okay, this year had a pretty good bump to storage, but a little bit on the below normal side of things. And then this is where we see Lake Powell. You know, this is a better fill than we've seen in Lake Powell in a lot of recent years, at least the best since 2019, if not beyond that. But you can see things are starting to level off here, where we're still kind of in the bottom 10 percentile of the historical distribution. So it would take at least one more year like this to get Lake Powell back anywhere near the kind of normal operating range. 2 more good snow years is probably really what it would take. I already talked about soil moisture, so let's see, I can move on there. I think there's one more thing that I want to show regarding water supply, and it's this here. It's the growing season water balance percentiles from our COAGMET, or Colorado Agricultural Meteorological Network stations. This is showing the percentile ranking of precipitation divided by potential evapotranspiration, so trying to account for both the water supply and water demand side of water balance. And you can see that percentiles across the Eastern Plains, and these go back to April 1, I should say too. It's not just May, so this goes all the way back through April 1. But you can see that percentiles across the Eastern Plains, all the way to the Continental Divide from these stations, well above normal. We do have some below normal numbers west of the Continental Divide. This 98 percentile, don't pay attention to that. That station is getting irrigated and needs to be QC'd out of the data set. But for the most part, west of the divide, things have been drier since about, May, certainly June. And so that's definitely something to keep an eye on, even though it was a good snow year, is that our west slopes have been drier lately. I think that's all I want to show. If there's any questions or comments, I'd be happy to field those. Alrighty, I will stop my share and kick it over to Becky.
Thanks, Peter. Let me bring up. Does that look okay to everyone?
Yep.
All right. So I wanted to kind of wrap this up with a look at kind of the drought situation that we're in, or lack thereof, and where we came from, so we can all give ourselves a pat on the back for what we just got through. So here's the latest drought monitor map for the lower 48 states, released last Thursday based on conditions through July 4th. And you can see that there are still areas of the country that are in pretty severe drought, especially nearby. Conditions in Nebraska and Kansas looking quite dreadful in a lot of the areas. And then moving east, as you go into the Midwest, things are also very dry there. And we're one of those bright spots in the country where we have no drought, no D0 through any category, and not a lot of states can say that right now. So yay for us. Zoom in here to see that we have no drought to speak of. So the table on the right shows the statistics, and 100% of the state is not in any category. The last time that happened was in May of 2019, and we stayed that way through part of July, I believe. So mid-May to mid-July, we stayed 100% free of any of the categories. Now, D0 is not a drought category, it's abnormally dry. So we haven't been in drought for a couple weeks now, and now we don't even have that abnormally dry category. You can see that the week before we still had 1.89% of D0, and 3 months ago, about 48% of the state was in one of the D categories, with almost 38% of the state in a drought category. And this is how that change has happened since, we're going back and looking at the changes that have happened in the past 3 months. So this takes us back to April 11th. So mid-April, before we got our May moisture, before we got our June moisture, things were still good on the west slope, everywhere west of the divide, just based on the excellent snowpack conditions that we had. So there wasn't any drought there already. But east of the divide, we had a lot of drought. And everywhere where you see those green colors is drought categories that improved over the past 12 weeks. So the light color is a 1 category improvement. So those were areas that on April 11th were in D0, now in nothing. As those colors get darker, that means they were in worse drought and had more improvements made. So around the Pueblo area and west of there, we had 4 category improvement in that area. So D3 drought that has gone to nothing. And then if you look in the southeast corner of the state in Baca County, we have that darkest blue color. That was an area that was in D4 drought and now has nothing. So we've seen a heck of a lot of improvement going over the last 3 months. And this is looking at the evolution of this last drought that we experienced. It's moved around the state, but basically it started after that completely drought-free time in the summer of 2019. And then things started to dry out in September of 2019. You can see we added D1 there. Things kind of hit the worst point, I would say, in the late summer and early fall of 2020, where you see that we had our largest coverage of D4 drought and D3 drought. Those are the maroon and red colors, the worst drought categories. And that D4, D3 stuck in place for a significant period there. As we went into 2021, the summer of 2021, our drought was really intense over northwest Colorado. And then as we got into 2022, it really intensified over northeast Colorado. And then since then, you've seen how it's slowly decreased out of the state to where now we're at nothing again. And this is looking at this in a larger context, basically since the beginning of the US Drought Monitor in 2000. And you can see that that most recent drought that we've gone through with 2020, 2021, 2022 on there is really just part of a pattern that we see where it is common for us to have drought in this state. So we had 2018 and into 2019, very significant over southern Colorado. Another significant statewide drought in 2012 that we really didn't completely get rid of until May 2015 with our Miracle May. And then obviously we've got that other significant statewide drought that occurred in 2002. And not to be the Debbie Downer, but just to show that it's much more common for us to have drought somewhere in the state than for us to not have drought anywhere. So we'll be keeping an eye, particularly on Western Colorado right now, for areas that could be going into drought development, because enjoy this while it lasts. Our drought free won't last forever. That's all I wanted to say about the drought coverage. If there's any questions on that, can take those. Okay, in the interest of time, I'm not going to keep us and talk about the outlook, but we will probably do a bigger focus on the outlook maybe for the next month's call. So for now, I wanted to announce our Climate Services Summit. Oh, our next month, we are not going to be doing the drought webinar because August 8th, we will be doing our climate summit at the CSU Spur campus in Denver. So August 8th and August 9th. And I'm going to copy and paste the link. Oh, nope. In the chat. We will be giving a brief overview of current conditions at the summit, but we are also going to be talking about a lot of other really cool things. There will be a big focus on drought. We'll briefly go over climate change and Colorado's future climate. We're going to have some great panel discussions. If you visit the link that you see on the screen or the link that I put in the chat box, you can register for the event. Again, it will be in Denver for 2 days, and we will be providing lunch. If you haven't been to Spur, it's a pretty cool location. So I encourage you all to come and join us and hang out with us in person instead of the webinar next month. So no webinar next month, and we will be doing the Climate Summit, and I hope you'll be able to join us. And if we have any questions or comments, I can take those now. All right, Russ, Peter, did I miss anything I should mention?
I would jump in, Becky, if I could.
Yeah.
Dave Kanzer here from the West Slope. Wanted to just,
hello.
Hey, really appreciate this, as always, a wealth of information and puts stuff into perspective. 2 things, one technical and one I think I know the answer to, but I'm going to ask anyway. On the Climate Services Conference, there's no hybrid option, right?
As of now, I don't think we are planning it. Russ, do you have follow-up on that?
Yeah, I mean, other people have asked. We're still thinking about it because we don't want to leave people out, obviously, and you know, it's not a short, quick trip for you or others from the West Slope. So we're still trying to work out, but we're also gonna, because we'll be having some breakout discussions and some other things that'll be hard to do with folks virtually. But yeah, so I guess stay tuned. We're still working out those details.
Sure, I understand that, and I would selfishly put in a vote for some hybrid. You know, some of the segments, some of the panels, understanding you can't do everything, would be great. And I would be there, but I just have some you know, commitments. So that's that. And then I wanted to comment and ask Peter and the rest of you on the team, you know, when you looked at and showed that really cool percentile or percentage of basically crop need that was being met by the COAGMET data. And you mentioned, of course, you know, those that show are dry are being supplemented by irrigation. And I was just wondering if you've done any work to further quantify, okay, so here's the deficit, that the natural fraction that's not being met by precipitation, and track that in some way so that the irrigators, you know, obviously in the West Slope, we wouldn't be able to grow much of anything without, at least in our valleys, without irrigation. So the metric doesn't work really well for us to understand that water demand for crop needs. So long statement, convoluted, but I think you got where I was going, and wondering if there's comments from you or the group.
Yeah, I have a couple things I can say about that. Becky, is it okay if I pull my screen up again?
Yeah, let me stop sharing.
Okay, so you were talking about this graphic, right? And now I want to say a couple things. The first thing is this Cortez station, or CTZ01, that's at the 98th percentile. What I meant when I said that it was affected by irrigation is that station's precipitation gauge is literally getting hit by the sprinkler. And that's why it shows up off the charts for water balance this year. And so don't pay any attention to that data point specifically. Now, your question about tracking water balance and water supply and demand, yes, that is absolutely a big part of what COAGMET does. And in fact, we can kind of look at that with some of our station graphics here. So Olathe, for instance, we can pull it up. We can look at the reference ET for this year. So the blue is in is the current year, the black is average. The red and green represent the high and low years, and then every trace in the middle is another previous year. We do the same for precipitation, and then water balance, which is, you know, precipitation minus reference ET. So you can see what the deficit is there. Now, if you're irrigating, will you actually have to put on 40 inches? Probably not, because this is just straight up American Society for Civil Engineers potential evapotranspiration, which when you apply a crop coefficient, especially a crop coefficient that varies throughout the growing season based on that crop's growth stage, is going to end up tailoring this down quite a bit. So these numbers are misleadingly bad in terms of how much irrigation you have to put on the crop, but another way to help keep track of the water balance. And there's other resources like that on the COAGMET website, if that helps answer your question.
Yeah, it sure does. That last plot, I hadn't seen that before. That seems like a real good way to track sort of the ag water demand in rough trending kind of statistics. So thank you for that.
Yeah, absolutely.
Thanks, Dave, for that. And yeah, our COAGMET website has a lot more ET products on it, like a crop water use and that sort of thing, and how to use that information. So definitely some more helpful, specific information for irrigators. Do we have any other questions? We did have one question coming on the chat that was asked if the climate summit is free to attend, and it is. There's no registration fee. So registration is limited. We don't have an unlimited number of seats. So if you are interested in coming in person, please visit the link when you can and register. And we will definitely try our best to see if we can offer some sort of hybrid option for those who are unable to make it to Denver. Anything else before we sign off? Okay, thank you all for joining, and hopefully we will see you in person next month. Otherwise, we'll see you on our next drought webinar in September. Thank you, everyone.